This video is over Lesson 69, Proper Form of Scientific Notation, and is for my 7th grade math class. In this lesson, we will learn how to take numbers that are partially in scientific notation and write them in proper form for scientific notation. In order to accomplish this, we need to know how to write numbers in scientific notation and the product of powers rule. So we're going to review those two things here to start off with. So first of all, scientific notation. Scientific notation is always of this form. So we have a number out front here. This is called the coefficient. And then we multiply by a power of 10. And so the key here is we just move the decimal so that there is only one non-zero whole number digit. So this could just be 5, this could be 4.27, 3.8, but there's only one whole number. You can have as much as you need to have after a decimal, but only one whole number digit. Over here, we choose a power of 10 that would move the decimal back to its original position. So here we move the decimal, so we have one whole number digit, but then this power of 10 would give instructions on how to move it back to its proper place. So remember, when we multiply by 10, whatever this number is, this n here, we move the decimal that many times. So you can see lessons 51 and 57 for more information and examples on this. So refer back to there if you need to. But just a quick review here. So with this problem here, if I scoot my decimal all the way over, so there's only one whole number digit, it's going to be that 4. So my coefficient will be 4.23. Very common error here is a lot of students want to just say 4. They forget that one whole number digit does not mean you can just scrap the 2 and the 3. So make sure you got that 2 and that 3 still. So now I need to multiply this by a power of 10, and this is going to give me the instructions on how to turn this back into this. So if the decimal is right there, I would need to move it 2 times to get to the end of that 3. And then I have a group of 3, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups of 3. So that's 18 more times. So 2 plus 18 is 20 times that decimal needs to move. Down here, I would have to move the decimal, though, this time this way until I have that 7 out front. So this would be 7.9 for my coefficient times 10 to the, now let's see if this was where the decimal was. We'd have to move it once, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 times. However, this is a very small number, so if we have to move the decimal to make this smaller, it'll be a negative exponent. So negative 21 for the exponent tells me to move the decimal to make it smaller. So that's scientific notation there. So next up, I said we need to know the product of powers rule. This is something we've already learned, so I'm going to try to keep this in my good light here, and on your papers, hopefully you can see the colors that I chose here, that when we have a power times another power. So notice here that these both have a base of 10, and that we're multiplying them together. So when that's the case, instead of multiplying powers with the same base, we can add the exponents. So these two will combine into just a single power, but then the exponents will be added together. So you can see lesson 47 in the math pyramid for more information and examples on that. So a couple little practice problems on that. If I have 10 to the 3rd power times 10 to the 4th power, then this is going to make 10 to the, and remember we're going to add the exponents, so 3 plus 4 is 7th power. Over here, if I have 10 to the negative 7th or negative 2nd power times 10 to the positive 7th power, this is going to be 10 to the negative 2 plus 7 power. So if we think about what we've been learning recently, we would go with an arrow that would go 2 to the left, and then this would come back 7 to the right, So if you think that through, if you kind of imagine those arrows, that is a result of 5. Or if you remember our rule, that if they have opposite signs, that we're really going to subtract them. So 7 minus 2 is 5. And then since the bigger number is positive, that's why it's a positive 5. So with those two ideas, we're ready to go ahead and tackle proper scientific notation. So first step is going to be to write our coefficient, the number multiplied by the power of 10, in scientific notation. So you'll notice in these examples here that I don't have just a single whole number digit here. I don't have any non-zero whole number digits here or here. And then likewise for these three, I have more than one whole number digit. So we need to change these so there's just one whole number digit. So first step is to write this number out front in scientific notation. The second step is to use the product of powers rule to combine the powers of 10. So here we go. 3,600, that would just be a 3.6, and then we'd have to move the decimal 1, 2, 3 times, so it'll be times 10 to the third power. Now, I'm going to change a million into a power of 10 as well. So a million as a power of 10 would be 10 to the 6th power. 1,000 would be 10 to the third, so a million is a 10 to the 6th. A billion would be 10 to the 9th, and so on. Now, step 2, we're going to use the product of powers rule to combine the powers of 10. So I've got a 10 to the third and a 10 to the 6th. So we're still going to have our 3.6, but now 10 to the third times 10 to the 6th, remember we add the exponents. So 3 plus 6 would be 10 to the 9th. So my answer here is 3.6 times 10 to the 9th. So 3,600 million is really 3.6 times 10 to the 9th power. 47.2 times 10 to the 12th power. I'm going to take my 47.2, and I've only got to move that decimal over once to make that a single whole number digit, which since I moved it over once, it'll just be a 1 up there. I'm going to move it one space to make it bigger. This has got to get bigger to turn back into a 47.2. Now 10 to the 12th will just get copied. Now I'm going to combine these, so I'll still have my 4.72. But now 10 to the 1st times 10 to the 12th, well, 1 plus 12 is 13. So in proper scientific notation, this is 4.72 times 10 to the 13th power. Ladies and gentlemen, as you start feeling more and more comfortable with these, I recommend that you pause the video and give them a shot and then press play again and see how you did. I'm going to keep moving through them though. So 58,000 times 10 to the negative 7th power. So 58,000, I've moved that decimal over. That's going to be a 5.8. And then the decimal would need to move once, twice, 3 times, 4 times. So times 10 to the 4th power. We're going to copy 10 to the negative 7th power there. And then we're going to combine. So I'll still have my 5.8. But 10 to the 4th times 10 to the negative 7th will be like 4 plus negative 7. So remember the signs are different. So we're going to actually subtract. So that'll be a 3. 7 minus 4 is 3. But since the bigger one is negative, it'll be a negative 3. So 58,000 times 10 to the negative 7th power is actually 5.8 times 10 to the negative 3rd power. Next up here, 0.25 times 10 to the 8th power. So this time I've got to move the decimal over here to make it 2.5. So I will need to move the decimal just once to change it back into that, but I'll need to make this smaller. 2.5 has to become smaller to go back to the original. So that'll be a negative 1 actually. And then I'll copy the 10 to the 8th power. Now for my final answer, I'll still have my 2.5, but now a negative 1 plus a positive 8. So different signs. I'm going to subtract. 8 minus 1 is 7. The big guy is a positive, so it'll be a positive 7. So 0.25 times 10 to the 8th power is really 2.5 times 10 to the 7th power. Down here, same idea actually as that one. I'm going to move that over to make it 3.6, but then I'd have to move the decimal two times, but make it smaller. I'm going to copy my 10 to the negative 4th, and so we are going to have 3.6 as our coefficient, and then 10 to the negative 2nd times 10 to the negative 4th. Well, that'd be like a negative 2 plus a negative 4. Since these have the same sign, we're going to add them. So 2 plus 4 is 6. But since they're both negative, it'll be a negative 6. All right. And last example here. Obviously, the 9 will be my coefficient. And I need to move the decimal 6 times to go back to the original. Now I'm going to copy down my 10 to the negative 5th. And so my coefficient is 9, but then 6 plus a negative 5. So different signs means I'm going to subtract 6 minus 5 is 1. And since the bigger number is positive, it'll be a positive 1. So this is really 9 times 10 to the 1st power. By the way, on this one, normally we wouldn't use scientific notation for a number like this because we know 10 to the 1st power is really 10. And then 10 times 9 is 90. So the answer there really is just 90. So again, normally we don't use scientific notation for numbers like that. We usually use scientific notation for numbers that are much, much bigger or much, much smaller. But that is what it would be in scientific notation. So let's flip over to the back now. And we're actually going to do the practice set. I copied the problem for you this time. But on the homework, make sure that you copy the problem. So we don't need to look at our book since I have it all typed up for us. But we're going to go through, and just like with the front, I recommend that if you're feeling pretty good about these, maybe take them just one or two at a time. I recommend that you pause the video and pause and play, and just see what you can do on your own. Always make sure to double check, though, back with what I've done. So here we go. First one, remember on the front, if you noticed, that I put parentheses around whatever this front number was, just to make it really clear that my 3,600 is this stuff that's inside the parentheses. So let's do that over here as well. So inside my parentheses, I'm going to change 0.16 into scientific notation. So that'll be a 1.6 times 10 to the, now 1.6, I'd need to move the decimal just a single time, but make it smaller to go back to the original. So this right here in parentheses is this right here. Now we just copy the 10 to the 6th power. That just comes over. And finally we put it all together. So 1.6 is going to be my coefficient out front. And then a negative 1 plus a positive 6 will make times 10 to the 5th power. Now I'm going to caution you here. Make sure that you put times 10. Very common error I see here is I see students that will forget to put times 10 and they'll just put 1.6 to the 5th power. That would not be scientific notation, nor would that be equal to the original. So make sure you don't forget that times 10. All right, moving on to the next one. 24 times 10 to the negative 7th power. So first of all, 24 in scientific notation, we'd move the decimal over just a single time, so 2.4. So single time, 10 to the 1st power. Copy the times 10 to the negative 7th power. And now we're ready to combine. So we will have 2.4 times 10, and then a negative 1 plus a negative 7. Well, we're going to subtract since they have different signs. So it'd be a 6, but the big guy is negative, so that's a negative. And of course, let's make sure that we circle our answers. Next up, so 30 times 10 to the 5th power. So move that decimal over, that'll be 3. And the decimal moved over just once, so times 10 to the first power again. And then times 10 to the fifth power gets copied. Now we're ready to combine, so that'll be a 3 out front, times, and then 1 plus 5 is 6. Next up, 0.75 times 10 to the negative 8th power. So 0.75, I move that decimal over, I'll get 7.5. I moved it over just once, but I'd have to make it smaller to go back to the original. So it'd be a negative 1. Copy down the times 10 to the negative 8th power. And now I have 7.5. Oop. It's a funny looking 5. 7.5, there we go. 7.5 times 10, and now a negative 1 plus a negative 8. So if I go 1 to the left and then 8 more to the left, that's 9 to the left. Next problem, 14.4. So I'll have to slide that decimal over once to make it 1.44. So if I'm moving it over just once, that'll be times 10 to the first. And we will need to make this bigger to go back to the 14.4. So positive 1. And then times 10 to the 8th power. And so my coefficient is 1.44. Times 10 to the 1 plus 8 is 9. And last one. So 12.4 will become 1.24. We'll slide the decimal over there. And in order to go back to the original, I'll have to move the decimal over once and make it bigger, so that'll be a positive 1 exponent. Times 10 to the negative 5th gets copied. So this means my coefficient is 1.24. And then my power of 10 will be 1 plus negative 5. So since they have different signs, we subtract, and then the bigger guy wins. Or another way to look at it, if you imagine on a number line going 1 to the right, and then go 5 to the left, we end at negative 4. And that, ladies and gentlemen, is our lesson.